Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have completed the second unit of the subject Digital Communication and Networking. In this video, we are going to start the unit third of this subject named as Multiplexing, Spectrum Spreading and Media Access Control. Let's start our today's topic, multiplexing and multiple access. First of all, we have to know the basic difference between the term multiplexing and multiple access. Let's see. The two terms multiplexing and multiple access are very closely related with each other. Both of them describe the process of combining of the signals. That means in both multiplexing and multiple access, the combination of the signals is performed. When all the signals that share a given channel originate from the same source, the process of combining them is known as multiplexing. Whereas when the signals originate from different sources are combined to use a single channel is called as multiple access. That means in multiplexing and multiple access, the combining of the signal task is performed. That means if this is the signal 1, signal 2, this is the signal 3, then the multiplexing and multiple access combines them into a single channel. But only difference is that in multiplexing these signals 1, 2, 3 are originate from the same source, while in multiple access these signals 1, 2, 3 are originate from the different sources. Okay, I hope you all get the basic difference between multiplexing and the multiple access. Now let's see the introduction to the multiplexing. We know that multiplexer means we can also say it as the many into one electronic circuit. The multiplexing is the process of simultaneously transmitting two or more signals over a single communication channel. The multiplexers are the circuits having many inputs and the only one output. Multiple input signals are combined by the multiplexer into a single composite signal, which is then transmitted over the communication medium. At the end of communication link, a demultiplexer is used to separate the signals into their original form. That means the multiplexer is an electronic circuit which has number of input signals but the only one, that means only a single output. Okay. Now this is the diagram of or the concept of multiplexing is shown, in which there are multiple input signals at the input of the multiplexer, but the output of the multiplexer is a single. Okay, this single communication channel, may be wire or wireless, is transmitted, and then at the receiver side there is a demultiplexer electronic device. The demultiplexer means it performs the opposite operation of the multiplexer. That means it performs one into many. That means it has only one input and the number of outputs. Okay, I hope you all get the basic idea about the concept of multiplexing. Now let's see the types of multiplexing in communication. There are many multiplexing techniques such as frequency division multiplexing, time division multiplexing, wavelength division multiplexing, code division multiplexing, and space division multiplexing. Generally, frequency division multiplexing and wavelength division multiplexing systems are used to deal with the analog information, whereas time division systems are used to handle the digital information. That means frequency division and wavelength division are used for the analog transmission, and the time division multiplexing is used for the digital transmission. The CDM, that means code division multiplexing, and space division multiplexing are used in wireless mobile communication system. Okay, now let's see the details about each type of multiplexing one by one. The first one is frequency division multiplexing. The operation of frequency division multiplexing is based on sharing the available bandwidth of the communication channel among the signals to be transmitted. That means many signals are transmitted simultaneously within the total available bandwidth. In case of frequency division multiplexing, each baseband signal is modulated on a separate carrier. Each carrier has the different frequency. The modulated carriers are then added together to form a single complex signal that is transmitted over a single channel. That means in frequency division multiplexing, the various frequency signals are modulated with the different carriers, and these carriers are then added into a single channel. This channel is now transmitted to the towards the receiver. Let's see the next concept, guard bands and their importance in frequency division multiplexing. The adjacent spectrum in the spectrum of the frequency division multiplexing signal do not touch each other. They are separated from each other by a guard bands. This is the frequency 1, this is frequency 2nd, this is frequency 3rd. These frequencies are originates from the same source. For example, here are the four frequencies shown. That means there are four input signals and single output signal in multiplexing process. This has F1, F2, F3, F4, and it is placed simultaneously on this output Y. Hence, during this combination, they are separated from a specific band. It is known as the guard bands. Okay, I hope you all understand the concept of guard bands. That means guard bands are separated from each other. Okay, or the guard bands separates the two frequency signals from each other. Okay, the guard bands are introduced in order to avoid any interference between the adjacent channel. Wider the guard bands, smaller the interference. That means if the guard bands are not present, then it may be possible that frequency first and frequency second signals are overlap with each other. That means when the two frequencies are overlap each other, then errors are introduced or the interference effect is introduced. To avoid this interference, the guard bands are placed to separate the two frequency signals from each other. Okay, I hope now you all understand the concept of guard bands and their importance in frequency division multiplexing. Let's see the frequency division multiplexing transmitter block diagram. In this block diagram, we can clearly see that there are n number of signals which are given to the linear mixer through a n number of modulators. That means signal 1 is given to the modulator 1, which is modulated at the carrier frequency fc1. The signal 2 is given to the modulator 2, where this signal 2 is modulated with the carrier frequency fc2. The signal 3 is given to the modulator 3, which is modulated at the carrier frequency fc3, and all these modulated signals then given to the linear mixer. This mixer means the multiplexer multiplexes all these input signals and combines them into a single composite signal or a communication channel. Okay, now let's see the detailed description about the FDM transmitter. The signals which are to be multiplexed will each modulate a separate carrier. The type of modulation can be AM, that means amplitude modulation, SSB, that means single sideband modulation, frequency modulation, or phase modulation. The modulated signals are then added together to form a complex signal which is transmitted over a single channel. Okay. Now each signal modulates a separate carrier. That means each signal, the signal 1 is modulated with the carrier frequency fc1, signal 2 is modulated with the carrier frequency fc2, etc. The modulator outputs will contain the sidebands of the corresponding signal. The modulator outputs are added together in the linear mixer or adder. These outputs are added together or multiplexed in the linear mixer or the adder circuit. The composite signal at the output of the mixer is transmitted over a single communication channel as shown in the block diagram. Okay. The signal can be used to modulate a radio transmitter if the FDM signal is to be transmitted through the air. I hope you all get all the information about FDM transmitter. Now let's see the FDM receiver. This is the block diagram of FDM receiver, in which this communication channel is originated from the FDM transmitter. Okay, this contains the number of frequency signals, or it is of a composite signal. In receiver, we have to separate these signals, hence we use a band pass filters which tunes or which passes a specific frequency band. Okay, that means band pass filter F1 is having central frequency FC1, band pass filter BF2 has central frequency FC2, as so on. Okay, then the signal is given to the demodulator. The demodulator removes the carrier from the modulated signal and we get the original signal as it is. Okay, now let's see the detailed description about the FDM receiver. The composite signal is applied to the group of band pass filters. Okay, the signal is given to the group of band pass filters. Each band pass filter has a central frequency corresponding to one of the carriers used in the transmitter, that is FC1, FC2 up to FCN. Okay, it has central frequency FC1, FC2 up to FCN. The band pass filters have adequate bandwidth of to pass all the channels information without any distortion. The channel demodulator then removes the carrier and recovers the original signal back. Okay, this is the total diagram of FDM transmitter and FDM receiver is shown, in which we can see here that the n number of signals are added into a linear mixer or in a multiplexer through a modulator. The signal 1 is modulated with the carrier FC1, the signal 2 is modulated with the carrier FC2 up to the signal N is modulated with the carrier FCN. Okay, all these modulated signals are added into the linear mixer and a composite signal is made. This composite signal or the communication channel is given to the receiver. At the receiving end, this composite signal is given to the number of band pass filters. Each band pass filter has the central frequency equal to the modulated carrier frequency, that means FC1, FC2 up to FCN. Okay, that means this band pass filter BF1 allows only the carrier frequency FC1 to pass through it. Okay, all these signals are then given to the demodulator. In the demodulator block, the carrier is removed and the original signal gets back. That means signal 1 is gets back here, signal 2 is gets back here, up to signal N get back here. Okay, I hope you all now understand the working of FDM transmitter and FDM receiver. Now let's see the multiplexing hierarchy in FDM. Okay, in frequency division multiplexing, the hierarchy is divided into 4 types, into basic groups, super groups, master groups and jumbo groups. The first one is basic groups. The basic group has, or the level 1 has, the 12 voice channels. Consider each voice channel has the frequency 4 kHz, hence the total frequency is here 12 into 4, that means 48 kHz, and it has the 12 voice channels in a single group or a basic group. That means a group has the 12 voice channels. Now the level 2 is the super groups. The super groups are made up of 5 basic groups. Okay, the super groups are made up of 5 basic groups, but a group consists of 12 voice channels, hence it consists of 5 basic groups. That means there are total 60 voice channels and the frequency becomes 240 kHz. The next group is master group. The master group is made up of the 10 supergroups. Okay, but each supergroup contains the 60 voice channels. Hence, total 60 into 10 equal to 600 voice channels are in the master groups, and its frequency is 2.52 megahertz. Now the next level, that means level 4, is the jumbo group. The jumbo group is made up of 6 master groups. Okay, the jumbo group is made up of 6 master groups, but each master group contains 600 voice channels. Hence the total channels in the jumbo groups are 3600 voice channels in the jumbo groups, and the frequency is 16.984 megahertz. I hope you all understand the multiplexing hierarchy in FDM. Let's see once again. There are 4 levels. First one is basic groups. One group consists of 12 voice channels. Then next level is supergroups. The supergroup consists of 5 basic groups. That means total 12 into 5 is equal to 60 voice channels. The next level is master group. The master group consists of 10 super groups. That means 10 into 60, we get here 600 voice channels. And the next level is jumbo group. The jumbo group consists of 6 master groups. That means 600 into 6, 3600 voice channels is in the jumbo groups. Okay, I hope you all understand the multiplexing hierarchy in FDM. Now let's see the next point, the application of FDM in telephone system. One of the important application of the FDM is the telephone system. Here each telephone signal is in the range of 300 to 3000 hertz. That means we know that our normal human speech range frequency lies between 300 to 3000 hertz. These voice channels are modulate different subcarriers. These modulated subcarriers are then added together. As the number of telephone channels are very large, the multiplexing process is repeated at the several levels. Let's see the block diagram of FDM telephone transmitter, or the formation of 12 channel groups. That means at the input side we have the 12 channels. That means 12 voice signal channels. Voice signal channel 1, voice signal channel 2, up to voice signal channel 12. Each voice signal channel is modulated with the different frequencies. For example, F1 is equal to 104 kilohertz, F2 is equal to 100 kilohertz, and F12 is equal to 60 kilohertz. These all frequency or the modulated signals given to the band pass filters, band pass filter 1, 2 to up to band pass filter 12, and they are all mixed together or added together in a linear mixer to make a composite signal. Okay, here the frequency plan for the typical basic group is shown below. Here 12 voice channels modulate the carrier frequencies in the range of 60 to 108 kilohertz range. That means from 60 hertz, by using the difference of 4 kilohertz, we get the range 60 hertz to 10 kilohertz. That means the first is 108 kilohertz, next is 104 kilohertz, next is 100 kilohertz, next is 92 kilohertz, etc. Okay, now let's see the advantages of the FDM. A large number of signals or channels can be transmitted simultaneously. FDM does not require any synchronization between its transmitter and receiver. Demodulation of FDM is easy. Due to slow narrow band fading, only a single channel gets affected. That means the FDM system is very important due to its various advantages. There are some disadvantages of the FDM, such as the communication channel must have a very large bandwidth. Intermodulation distortion takes place. Large number of modulators or filters are required. FDM suffers from problem of crosstalk and all the FDM channels are get affected due to the wideband fading. These are the disadvantages of the FDM. There are the number of applications of the FDM. Some of them are listed below, such as the FDM is used in telephone system, it is used in amplitude modulation and FM modulation radio broadcasting, it is used in TV broadcasting, and it is used in first generation of cellular phones. I hope you all get all the basic details about the frequency division multiplexing technique. Thank you.